I'll be honest. When I first heard the term OEE, I kind of tuned out,
Yeah.
factory jargon, not for me.
Right.
But then I got to digging into it for this deep dive we're doing. And
Yeah.
honestly, it's like this whole world opened up.
It is.
It's like relevant to everything, not just factories.
Yeah, it's about systems.
Okay, so we're talking OEE,
Yeah.
overall equipment effectiveness.
Yeah, overall equipment effectiveness. It's a mouthful.
It is, but
It's a good one.
it's powerful.
Yeah.
So how do we...
And what's fascinating about it is it's not about like pushing harder.
Okay.
It's about understanding the systems and like finding those bottlenecks, those hidden things, and figuring out how to make them sing.
I like that.
Like fine-tuning a high-performance engine. Yeah.
Okay, so break down this engine for me. We're talking about availability, performance and quality, the three-legged stool. If one of those legs is out of whack,
The whole thing collapses.
the whole thing collapses.
Yeah.
And we've got a great article that we're going to dive into today that uses the example of a drip irrigation factory.
Okay.
Which I thought was really interesting because, I mean, how complex can making these little plastic things be? Turns out, very.
It can be, and the thing about this framework is it helps you analyze any operation.
Okay.
Whether it's a massive production line or it's just you in your office, right?
Right.
It's a lens.
Okay, so let's start with availability. First leg of the stool.
Okay.
Seems pretty straightforward. Is the machine on or off?
Well, not so fast.
Oh, boy.
Availability is a little more nuanced than just on or off.
Okay.
It's really about understanding all the factors that impact the machine's ability to be productive in the first place.
Okay.
So you can think about your car.
Okay.
Your car can be running.
Yeah.
But if you have a flat tire or an empty tank, you're not going anywhere.
Right. You're not going anywhere.
Right.
So it's more than just
Exactly.
clipping the switch on.
Yeah.
What else can sideline a machine that's technically available?
So the article talked about two types of downtime.
Okay.
Planned and unplanned.
Okay.
And planned downtime is just a reality
Sure.
of any operation.
Yeah. It's got to happen.
Shift changes,
Right.
breaks, routine maintenance. You got to swap out products on the line.
Yeah.
That's all planned downtime.
Things you can't avoid.
You can't avoid it, but you can minimize its impact.
Okay.
And so the article gave a really good example of that, talking about this drip irrigation factory.
Yeah.
They operate in 3 8-hour shifts,
Okay.
and they factor in planned downtime right from the start.
So they know.
For breaks, for shift changes,
They got it.
and that leaves them with 360 minutes per shift for actual production.
Got it. So those are the knowns.
Those are the known.
What about the unknowns, the unplanned downtime?
Yes, the unplanned downtime.
That's gotta be.
That's the productivity killer.
Yeah.
According to the article, when you have equipment failures, material shortages, anything that brings that production line to a halt unexpectedly,
Wow.
that's where you get those ripples. It just throws everything off.
Ripples, yeah.
Think about it, like you forget your laptop charger,
Oh,
one small oversight
Yep.
derails your whole day.
And I imagine those are the things that are harder to get a handle on
Absolutely.
because they're not
You
planned.
can't predict when a machine's going to break down or when a shipment's going to be late.
Right.
So that's where you really need to dig into the data,
Okay. Yeah.
analyze those events, and figure out what's going on.
Interesting.
Are there underlying maintenance issues? Are there kinks in your supply chain?
So it's like detective work almost.
It is. You got to find those weak points.
Interesting.
Yeah.
So we've tackled availability. We made sure the machine is up and running,
Okay.
but now we got to make sure it's actually performing, that it's, firing on all cylinders. Firing on all cylinders, right? So that's...
Exactly. Yeah. Performance is about making sure that available time is used effectively.
Okay.
And it's not just speed, it's like the right speed. Consistently, right.
Right.
Think about a marathon runner. If they go out too fast at the beginning,
Right.
they're not going to win the race.
Blown all their energy.
Exactly. They've got to maintain that pace.
Yeah.
It's the same thing with machines.
Interesting.
Sometimes slower and steadier is actually better for the long run.
So what can throw off performance?
Well, the article I thought had some really interesting stuff about like these things called minor stops.
Minor stops.
Yeah, they sound, I don't know, almost cute.
Yeah. Harmless.
Yeah, but they're not.
Really?
No, they're these tiny little delays
Okay.
that by themselves might not seem like much. But when you add them all up, they can really put a dent in your output.
So, like, what are we talking about here? Give me an example. What's a minor stop?
So they were talking about this drip irrigation factory.
Right, right.
And they found that one of the biggest causes of these micro delays were blocked sensors.
Really?
Yeah. Like
Wow.
dust,
Just like a little...
just a little bit of dust accumulating on a sensor
Huh.
could cause a brief pause in the production line.
I never would have thought about that.
Right.
Wow.
But the article said that just one blocked sensor can cause an average of 3 minutes of downtime per occurrence.
3 minutes
3 minutes.
from a little dust.
And now multiply that by however many sensors are on a production line
Oh, boy.
and how many times a day that happens.
Yeah, that adds up quick.
Yeah, and then
Death by 1,000 dust particles.
exactly. And that's just one thing, right?
Oh, boy.
We've got to think about like lubrication.
Oh, right. Yeah.
Too little and the machine's struggling.
Struggling. Yeah.
Too much and you risk contamination.
Right, right. Got to get that Goldilocks amount.
Exactly. And then even just things like ambient temperature in the factory.
Really?
Oh, yeah, humidity.
Oh.
You know,
Wow.
all these things that can impact performance in subtle ways.
So it's like all these little things
That all adds up.
you got to be mindful of.
Be mindful. You got to manage it.
Wow, it's making me look around my office like what's slowing me down that I don't even realize.
That's a great way to think about it.
Right.
What are your minor stops?
Yeah, what are my minor stuff?
That email you got to dig out, the file you can't find, you know?
Right, right. Coworker pops in with a quick question.
Exactly.
Yep, those are my minor stops.
Those minutes add up.
Yeah, they do.
You got to manage those too.
Okay, so we've got availability, we've got performance.
Yeah.
But even if we got those two things humming along, we still got to make sure that what we're producing is actually good.
Of course. Yeah.
So that brings us to the final leg of our OEE stool. Quality control.
We're not just making stuff. We're making good stuff.
Right, exactly.
Yeah.
And I would imagine the cost per quality it's got to be huge.
It's huge. You're wasting materials. You're wasting time.
Rework, yeah.
Yeah, got to go back. Got to fix it. Got to identify those defects in the first place.
Right back to our drip irrigation friends.
Right.
That
Man.
little defect.
A tiny defect in a dripper
Yeah.
multiplied thousands of times over.
Yeah.
Suddenly, it's a huge problem.
So how are we defining quality in terms of OEE?
So the article talked about two main types of quality loss.
Okay.
You've got production defects.
Okay.
And you've got reduced yield.
Okay. So production defects, that's like the obvious stuff.
Yeah. Wrong dimensions, faulty assembly, you know, packaging issues.
Just like clearly doesn't meet the standard.
Exactly. Those are usually pretty easy to measure. You can see it.
Yeah.
But then you've got reduced yield, and that's a little trickier.
Okay. How so?
Well, this often happens during like the initial phases of production.
Okay.
You know, like when a machine first starts up, it needs to kind of warm up.
Right. Like my old car in the winter. I
Exactly.
had to let it run for a
Gotta
minute.
get going.
Yeah.
So even though the machine's technically running during that time, it's not necessarily producing at its full potential.
So it's like it's on, but it's not.
It's not quite there yet.
Not in the zone.
Yeah, and the article had some interesting points about how like warm-up times can vary so much between different types of machines.
Oh, I'm sure.
Like a high-speed stamping press might take 15 minutes to get up to speed,
Okay.
but a plastic injection molding machine, that might take an hour,
Wow.
plus a bunch of test runs.
So you got to factor that in
I gotta factor it in.
to the whole OEE calculation.
Absolutely, it's all connected.
Wow. This is fascinating stuff. But like, how do we actually measure this? Is there a magic formula for OEE?
There's the formula, isn't there?
There is.
I knew it.
There is, but it's not magic.
Okay.
And it's not that complicated.
Okay, good. Because remember, it all comes back to availability, performance, quality.
Right.
Those three things, we multiply them together, that's how we get our OEE score.
So if you have perfect availability,
Yeah.
perfect performance, perfect quality.
Then you've got 100% OEE.
Okay.
Which, let's be honest, you're never going to get.
Not in the real world.
Not in the real world. It's
No.
like finding a unicorn
Right.
in a factory.
Right.
It's not going to happen, but that's okay.
Yeah.
Because the real value of OEE is not about chasing this mythical perfection.
Right.
It's about understanding where those opportunities for improvement are.
So where do we even start? Let's go back to our drip irrigation factory.
Okay.
How are we actually calculating OEE for them?
So remember, 3 8-hour shifts.
Right.
We look at availability first. They've got 360 minutes per shift for actual production.
After they factor in all the planned downtime.
Exactly.
Yeah.
But just because that machine's available
Yeah.
doesn't mean it's performing at 100%.
Right, those minor stops.
Exactly. So let's say their ideal cycle time, 2 seconds per dripper,
Okay.
which means in those 360 minutes, they should be cranking out 10,800 drippers.
Okay, that's a lot of drippers.
That's a lot of drippers, but they
Yeah.
only made 7,212.
Oh, so they're down a third.
They're down a third, and then we got to factor in
Well,
quality.
Oh, right. We haven't even gotten to that yet.
So out of those 7,212, let's say 8,803 had defects.
Okay.
Not good.
So what does that actually work out to in terms of OEE?
So when you do all that math, you're looking at an OEE of 37.3%.
37.3.
37.3%.
Wow. So they might think they're doing okay, but that number tells a different story.
Exactly. And that's the beauty of OEE. It shines a light on these hidden inefficiencies
Right.
that you might not otherwise even notice.
Yeah.
Suddenly, those minor stops, those little slowdowns, they become very visible.
And actionable.
And actionable. That's the key.
So for our listeners out there who are like, okay, fascinating, but I don't run a factory,
Yeah.
what's the takeaway?
It's all about thinking about your own ideal output,
Okay.
whatever that is, whether you're designing a website or writing a book.
Yeah.
There's going to be an ideal way to do it.
So what are my availability, performance, and quality? What are the bottlenecks in my own life, in work?
What are your minor stops?
Yeah, what are my minor stops? I'm going to be thinking about that all day now.
And how can you optimize? How can you get better?
It's a continuous improvement mindset that we can apply anywhere.
Absolutely.
So listeners, think about it. What's your OEE? Hit us up on social media. Let us know. We want to know. Until next time, keep those productivity levels high.